Hi, it's Miss McClellan. I'm going to go over homework 4.6.5 for AP Stats, and you asked for all of the odd questions, so I'm doing them all. First problem, number 1. For each of the following situations, determine whether or not the given random variable has a binomial distribution. Justify our answer. So to check if a random variable has a binomial distribution, I'm going to be checking BINS. B is for binary. I is for independent. N is for fixed number of trials. And S is for the same probability of success for every trial. Let's look at part A. Okay, this is a bookstore, top read shelf. 4 out of the 20 books are by the same author. I'm going to check B, I, N, and S. Let's see. 4 out of the 20 books are the same author. Let me see. So is it binary? Yes. A book is either by the author or it isn't. Is it independent? Well, let's see. I select 3 books from the shelf. So actually, no. Because books are selected without replacement. And then I don't really have to check N and S because we have a failure. So this is not binomial. Because we don't have independence. For the trials. Okay. Next problem. Oh, that's messy. Okay. The internet at a certain cafe is not working 4% of the time. I'm going to be checking B, I, N, S. Suppose you and your friends let each go to the cafe once at a random time over the span of a month, independently of one another. Let Y be the number of people in your friend group who go to the cafe and can access the internet. So let's see. Do we have binary? Yes. You can either get online or you can't. Okay. Do I have a fixed number of trials? Let's see. Yes. We are a group of 5 friends. So yes. N equals 5, and we're each going to go once. Do we have independent? Yes. It's given that our trips are independent. And do we always have the same probability of success? Yes. P is equal to 0.04. And then you've checked your conditions and you have to write your conclusion. So the conclusion is, yes, this is binomial, since we meet all the conditions. period. We met B-I-N and S. Okay, let's do the next problem, number 3. Okay, here we go. The probability that it rains in London, England on a randomly selected day in April is 0.3. Kira will lead walking tours in London for 5 randomly selected days in April. She says that the probability of it raining on exactly 1 of her 5 days is the same probability of it raining on exactly 4 of her 5 days. Giving tours, since there are always 5 ways to choose 1 out of 5. And also 5 ways to choose 4 out of 5 days. Okay, do I agree? That's a lot. So let me just see what they're asking. Say exactly 1, exactly 4. I don't agree. So, okay. Sorry. It's true that 5C1 equals 5 choose 4. So the number of ways you can arrange, let's say we have it rains 4 of the time. Rain, 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 sun. You can arrange this 5 ways. You can also arrange this 5 different ways. But the probabilities are still not equal. But the probability that, I haven't defined it, but I'm just going to say x anyway, x equals 1 does not equal the probability that x equals 4, just because the combinations have the same number of combinations. And that's because this is the probability that it rains 4 times in a row, 0.4 to the 4th, times 0.96 to the 1. And this is 0.96 to the 4 times 0.4 to the 1. So in order for these two probabilities to be equal, it would have to be that these two statements were equal. But actually, 5 times 0.4 to the 4 times 0.96 to the 1 does not equal 5 times 0.96 to the 4 times 0.4. Oh, sorry, I made a mistake. I'll fix it right now. Oop. Getting rid of those 9s. To the 1. Like, these are definitely very different things. Just because the 5s are the same doesn't mean the probabilities that x equals 1 and the probability that x equals 4 are the same. Okay, I'm going to go to number 5 now. Number 5. Joseph Girard III of Clemson University currently holds the record for the highest free throw percentage in men's college basketball, as reported by the association governing college athletics, the NCAA. His free throwing percentage is 0.95, which represents the percent of free throws he successfully makes. Assume he makes this successful rate, maintains this success rate, and that his free throws are independent. Consider the next 94 attempted free throws. Okay, so we've got fixed. Let x be the number of free throws Girard makes in the 94 free throw attempts. How many do we expect him to make? Okay, well, I've got a binomial distribution. Let me just double check that it's binomial. I know it is, but I'm going to check anyway because I want you to be checking. B-I-N-S. Binary, yes, you make it or you don't. Independent, yes, it's given. Fixed number of attempts, yes, that's 94. Probability of success is P equals 0.95 always. We know because it said maintained. Okay. So for part A, that's going to be the average that we would expect him to make if he were to do this many, many times. And that's going to be 94 times 0.95, which is 89.3. Calculate the probability that x equals 89. Okay, the probability that x equals 89 is equal to 94, choose 89, times 0.95, 89 times 0.05, 6, 89, 90, 91, 92, 93, 94. Nope, 5. Okay, I put that in my calculator and I get 0.0934, and I interpret it. Do I have room? Okay, I'll just write it right here. The probability that Gerard makes exactly 89 shots is 0.178. Oops, sorry. I'm looking at my solution for the next one. That was wrong. Okay, sorry about that. 0.1785. 0.1785, period. Okay, part C, calculate the probability that he makes at least 92 of his free throws. So that's the probability that x is greater than or equal to 92, which is equal to the probability that x equals 92 plus the probability that x equals 93 plus the probability that x equals 94. And gross, you have to like do this formula every single time. So that's equal to these added together after using our binomial distribution formula, and if you do it, which I really don't want to, so I'm not going to, is 0.1454. Okay. All right, that's number 5. Let's do number 7. Number 7. Okay, number 7. When people apply for their driver's license at the Department of Motor Vehicles, their eye color is recorded. In the US, the proportion of people who have blue eyes is 0.27. What is the probability that at least one of 5 people who apply for a driver's license on a particular day has blue eyes? Okay, the probability of at least 1 is equal to 1 minus the probability of none, which is equal to 1 minus the probability that it doesn't happen, which is 0.73 5 times in a row. And that is equal to 0.7927. Another way you could do this, which I don't necessarily recommend, would be the probability that x is greater than or equal to 1, and then you could say that equals the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5. And then for each of these, you would do n c whatever it is you're doing, in this case I'm doing 1, times the probability of success, which is 0.27, once times 0.73, in this case it would be to the 4th, plus ... You do all of them and you add them together. Okay, that's the last problem. Thanks for watching. I hope you have a great day.